I think in this talk, I want to raise awareness of evidence-based learning processes and highlight, especially how reflected, but also self-regulated learning are key to fostering sustainable competence or skill growth among students. So with this, I want to focus on the following key question in my talk for, let's say, the next 30 minutes. So it doesn't work. Now it works. So my key question is, what role do students' self-regulation skill play in the acquisition of research skills, and how are these two areas related? And with this question, I want to start with this friendly, nice guy, Robert F. Kennedy Jr., who recently said common sense is often more helpful than science. And I think that's a big problem, that these people are in digital media or social media with these sentences, and our students in school or in university are confronted with that. So especially recent studies reveal a worry trend with far-reaching negative effects on these social discourse. So for example, this guy, like people with extreme attitudes towards science, whether positive or negative, are more likely to believe that they understand it well. So earlier work from Fernbach and colleagues confirmed that opponents of science often have less knowledge, but excessive self-confidence, which leads to polarization and misinformation. So we need to promote students' research skill and especially even more on the base of trust in science. But how do we get there? Let's have a look on a quote from Andreas Schleicher. He is a director of the OECD, who is responsible also for the PISA studies. And he said, education today is much more about the way of thinking, which involves creative and critical approaches to problem solving and decision making. It is also about the way of working, including communication and collaboration, as well as the tools they require, such as the capacity to recognize and exploit the potential of new technologies, and so on and so on. If we focus on the important part of what he's saying there are creativity, critical thinking, communication, and collaboration within the potential of new technologies. And if we focus on these 4 or 5 parts, we directly come to the point of the 21st century skills, like in the so-called 4 C's of education. I also added the part on information literacy and media literacy or data literacy, because I think it's an overview on a literacy part that it's included in the 4 C's, but it's separated as well. So when we talk about the research-based learning, we are not only focusing on the scientific methods, it should be, but also on developing essential skills that make somebody a good researcher. Each of these is crucial in, for example, authentic learning situation. For example, communication, we all know, is needed to share findings clearly. Collaboration ensure teamwork in project. Critical thinking helps analysis data and questioning the results. And the creativity, in my opinion, it's the most important part, is necessary for designing new approaches and also solutions. In addition, I also said that 2 more aspects are becoming increasingly important, especially today: information literacy or critical information literacy, media or the data literacy. Within the overwhelming amount of information available, researchers must know how to identify it, evaluate, and let's say use reliable data source efficiently. So when we ask the question here, what are the basic research skills of a good researcher, we see that it's not only about technical know-how, but about a combination of these broader 21st century skills that allow students and researchers to work efficiently and responsibly. With this, we can ask the question, why should we focus on promoting research skills? So let's resume or bring that together. Promoting independent thinking and action in complex chemical research and teaching projects. Then strengthen evidence-based approach to ensure the quality and credibility of research and the curricular innovation, like research-oriented teaching. That's way more important than it ever was. Enable students to deal with complex problems systematically and independently. Colleagues like Klima and Harting define student research skill as a cognitive performance that can be learned, for example, on university, and use the research process, and that can be applied functionally to situation and requirements. For example, during the research-oriented teaching that we have in practical lab courses, or when we are working on the thesis in the domain or in our research topic. So what we can see here is a structured overview of what constitutes research skills based on the German RMRKW model. If we translate it in English, it's I for information skill, M for method skill, R for reflection skill, and C for communication skill. But also the W, that's the subject-specific knowledge that somebody needs to have if he wants to have a good base on the research skill. At the bottom, we have the subject-specific knowledge, for example, here the chemistry, that refers to the declarative knowledge in our discipline, knowing the key theory, the method, the finding, and so on. This forms the theoretical base that every researcher needs. About that, we see on the other, on the top, we see the procedural knowledge which represents the practical side of doing research. Like I said, the information skill, the ability to systematically search for literature, for example, evaluate sources, recognize contradictions, or identify research needs. The method skill that includes formulating research questions or the hypothesis, planning or conducting research processes, and applying suitable analysis methods. The reflection skill, these are about critically reflecting our results, the method and ethical aspects, for example, of our research. And communication skill, like I earlier said, writing scientific paper, communication with others or communicating with others, presenting findings, and engaging scientific discourses. You'll notice that the research data management appears in each of these areas as a theme, as a part of it. This underlines how important it has become as a transversal skill that connects all stages of the research process, from collecting and analyzing data to sharing and presenting it. So there are methods on measuring that, like a questionnaire we use. I'm not focusing on that today, but there are ways to measure research skills from students, for example. But let's come to an important point. Building strong research skills, like we all know, because we are all good researchers, doesn't happen overnight, for example. It takes time and needs to be developed step by step, often across multiple bachelor and master courses. The diagram on the right side shows a typical research cycle in an experimental lab, for example, in a bachelor-master course. It starts with the pre-experimental activity, such as recognizing the task, activating prior knowledge, asking meaningful questions, building hypotheses, and planning the approach. These steps are crucial because they prepare students for the actual experimental work. Next come to the experimental activities, running the experiment, then analyzing, interpreting the findings, and so on. Here, students put their plans into practice and begin making sense of their data. Finally, the post-experimental activities focus on connecting knowledge in other words, integrating what has been learned into a broader scientific context. If you see the feedback loop on the side, which reminds us that research is rarely linear. Each cycle is planning, experimenting, and interpreting results, feeds back into the next round of research. Let's have a look on this really cool study from Paul Kirschner and colleagues. They asked experts like you and me out of the educational research area the question, what should education look like in an age where we don't know exactly what our students will need to know in 5 or 10 years' time? And there was a clear answer of these experts. They say, especially like after analyzing all the interviews, we need to do more than just taking correct information's problem-solving skills into account. The experts state that we should also work on having them acquire cognitive and metacognitive skills, as well as transferring these skills to different domains. There are 3 important components named cognitive, metacognitive, and transfer. And if we add students' motivation to that, we come to a really important component, and that's self-regulation. So let's take a closer look on what self-regulation actually consists of. It can be broken down into 3 main components, like we just heard. It's the cognition. This refers to the use of strategic knowledge and the application of learning strategies. For example, knowing how to summarize, structure information, or apply different problem-solving approaches. Then the second part is the motivation. Here we are talking about the action and beliefs that keep learning going, like setting small rewards, having confidence in one's own ability, like the self-efficiency, or understanding why success and failure happens, like the attribution of patterns. The metacognitive, it's the most complicated part. This goes one step further. It includes planning and reflecting in one's own learning process, adjusting strategies when necessary, and observing one's own performance. Together, these 3 areas, cognition, motivation, and metacognition, form the foundation of an effective self-regulated learning. And it's exactly this combination that helps students take ownership on their own learning processes, like we heard earlier from Andreas Schleicher, and prepare for unpredictable changes or challenges in our future. I have a definition of self-regulated learning from my colleague Ferdi Stebner and Joachim Wirth from 2020. They're the University of Osnabrück and Bochum. And if we have this definition of the word self-regulated learning, I want to focus on the main important part of this definition. Self-regulated learning is much more about than just using the strategy, like time planning or setting goals, for example. It's taking the responsibility for one's own learning, and especially the process. It involves, for example, setting one's own goal independently, selecting and applying learning strategies, and being able to observe, evaluate, and reflect on process. Learners also need to balance external conditions, such as deadline or available resources, which their internal resources like motivation, prior knowledge, and effort. That's why we say self-regulated learning is like an engine for independent competences or skill development. So it drives students to continuously grow, adapt, and learn in new situations. So what we've done so far in the last 2 semesters or 3 semesters so far is to investigate the relationship between these two constructs I already talked about, the self-regulation and the research skills. There's a clear trend here, but let's have a look. It's only 58 students, a clear trend. With a high level, when students have a high level on self-regulated competence or skill, they also have a high level on research competence. This is almost obvious as we are talking about people who are good in structuring themselves, organizing their action. For this reason, I would like to examine in more detail in further studies how we can promote self-regulation among students so that they can develop their research skill more efficiently or better. And furthermore, if we have a look on the literature, it's not only just a guess that we have compared these two constructs with each other. It's if we have a look at the literature, we see that it is in various other contexts, self-regulation is a fundamental skill for acquiring further competences and in particular for learning. First, we see, for example, Price and Lübke say self-regulation processes are central aspects on the research process, especially since self-regulation is a sub-competences of research-based learning. In another, like my own study, we focused on a part that the phases of this inquiry-based learning, they show a number of similarities and demonstrate a positive correlation between these two constructs. And the constraints for measuring research-based and self-regulated learning that I haven't shown in detail, but we can discuss later, show high similarity or in some case even identically areas of competences. So what we have done so far on the RPTU in Kaiserslautern is to identify courses in which aspects of basic research competences can be integrated on the basis of self-regulation inputs. For example, we have let's have a look later on that. For example, we have 4 90-minute strategy seminars that are offered in the analytical chemistry lecture and the practical course that's called experimental technique or experimentelle Techniken. And in these seminars, 8 metacognitive and resource-related learning strategies for chemistry learning. We demonstrated using specific situations from learning or working in the laboratory or learning in analytical chemistry, and tried it out in small practical exercises. Like students received our corresponding interactive worksheet material that's also open as an open educational research material for each strategy they develop, for example. Then we have further courses, especially in experimental courses that we have been identified and will now be enriched with concepts of research-based learning and thus also with elements of research data management in this new funding phase that just started in October. The second run of the seminar in the 6th semester that is shown on the left side, that's called Instruction for Self-Regulated Scientific Work Using Digital Methods, that just currently started on Wednesday. As you can see here, the first block begins with central aspects of research data management, including, for example, the learning videos or the material from the working group of Sonja Harris-Papis. I've said that already, and we have already included the ELN Chemotion in the organic chemistry practical course. And these are the potential other courses where we want to include more of self-regulated based learning and forming our good researcher in the bachelor program of the RPTU University Kaiserslautern-Landau. So I want to end with my talk already. I've talked very fast, so I have some take-home messages. Self-regulated or self-regulated research-based learning increased transparency in the research processes. I think that's that came out of the first slides especially, and it's really important, the curricular integration of the research skills within the learning processes, also about research data management that requires self-regulation. And I think it's really important, and that's not a take-home message out of my slides, but I want to give that as a message that we can discuss later. Transfer concepts are needed that bring especially evidence-based and evaluated concepts to other universities, so that research data management becomes a fundamental and essential part, especially of chemistry teaching there as well. So my key question for my talk, I think I solved that with the first take-home message. And I have two other questions that I want to discuss with you guys for the next 30 minutes. So how can courses that offers in the NFD ICAM network be evaluated? So where is the need? Where can I help? So where is my position in this part? And if we have already these evidence-based concept on university, how do we get them to other universities so that it's just a fundamental part on our education? With this, I want to end, and I want to discuss with you guys.